Step 6.1 will show the assessment of global inconsistency. The Q statistic and p-value will allow us to decide if there are inconsistency between the studies. If you find that the results appear as null, it may indicate that you only have 2 treatments in your analysis. In this case, this outcome is not really a network meta-analysis but a standard meta-analysis. Hence, global inconsistency cannot be calculated. Besides, if the results totally do not show up, this may indicate that the data provided by you has inconsistent treatment estimates or negative treatment arm variance. In other words, the results contradict themselves and logical estimates cannot be calculated. In step 6.2, we assess the local inconsistency and visualize them with a network heat map. You can learn about how to interpret the graph by reading the explanation here. Do note that if the graph does not appear, it could either be that there is less than 3 treatments in this outcome, or this network donut has a closed loop. You can check the network graph in step 7 to verify if you have a closed loop. For example, outcome 3 heat map doesn't appear. Let's go and check in step 7. Indeed, it doesn't has a closed loop. Step 6.3 Assess local inconsistency again, and this time via net splitting. You can refer to the explanation here to help you with interpretation. If the network doesn't has a closed loop, the net splitting results will not appear. In general, if p-value is more than 0.05, it means direct and indirect evidence agree with each other. In this case, you can confidently use the combined network estimate for your conclusion. If p-value is less than 0.05, this means there is significant local inconsistency. The direct and indirect evidence are conflicting for that specific comparison. However, you do not need to panic over this, as inconsistency is common in network meta-analysis. You should investigate the studies. Are the studies in the direct comparison clinically or methodologically different from the studies forming the indirect loop? You should check differences in dosages, patient severities, etc. Remember that due to the local inconsistency, later on in step 13, you should downgrade the certainty of evidence for that specific comparison due to incoherence. Finally, in step 6.4 we have the forest plot. This forest plot will show you the direct estimate, indirect estimate and the network estimate for each treatment. You can check the explanation here for plot interpretation. Usually we will interpret the forest in such a way that if the effect size and confidence intervals are on the side of treatment, it means that it favors treatment. Or if it is on the side of control, that means it favors control. Hence, you can answer this question on whether higher value in the experimental group than the control group favor experimental or control group. By answering this, the direction of the label on x-axis will switch. This will also influence the ranking results in step 10 later. Meta-IMU also allows user to change the lower and upper limit of the x-axis. You need to state the value for both lower and upper limit for the effect to take place. If you notice that some parts of your forest plot are truncated, simply go to the side panel and adjust the slider. Increasing the height of the forest plot will allow the full image to be displayed properly. If some of the forest plot are too narrow and get truncated, you can adjust this slider to make it wider. Finally, if you find plot here is too small, you can enlarge it by adjusting this slider. Do note that the heat map above can also be controlled by the sliders in the same manner.